Hello and good afternoon. Welcome to this webinar, Switch to the Hybrid Energy System. My name is Jan-Willem Wagenaar and at TNO, I'm Program Manager Wind Energy. I will be your host for this afternoon. We have many people attending to this webinar, which is very great. Representatives from industry, from government, from research institutes and various others. This both nationally as well as internationally. As said, we are very pleased with this huge number of attendees to this webinar. Allow me to guide you through the program of today, and while doing so, introduce the speakers here in the studio to you. The central theme of today is the future energy system and what role a newly raised facility called Switch plays in the whole energy system, so to say. And we'll do that by taking three different perspectives. So after a brief introduction from my side, I will give the floor to my colleague Irache Gonzalez Aparicio. Irache is R&D Portfolio Manager, System Integration at TNO on Wind Energy. And she will present on how smart energy systems support the implementation of a large amount of wind power in the energy system. So Irache, thank you and welcome in the studio. Besides, we also have Chris de Visser and Floor Schipper in the studio. Chris is Business Unit Manager at Wageningen Research, and he will present on weak grids in rural areas. And Floor, she is Manager Shore Power of the Shore Power team at the Port of Rotterdam, and she will shed her light on how the port uses green electricity to electrify the port. Also, Chris and Floor, welcome in the studio. And here once more the program on the slide. Before we continue, it is good to know that you're allowed to ask questions during this webinar, and you can do that by using the button below at the bottom right in your video screen. We very much encourage you to ask questions. They will then pop up in my screen so that I'm able to pose them here to the speakers. So after this introduction about the program of today and introduction of the speakers, I will now kick off and introduce the importance of wind energy in the energy system and also give an introduction about the Switch facility itself. In fact, this webinar is a series of two. We've had a webinar end of last year, and that was entitled Offshore Wind Under Pressure. We presented various scenario studies towards 2030 and looked at business cases and so forth. In the second webinar of today, the Switch facility is the central theme, and we'll address that by considering different use cases, as I said. Why we do this? Well, in order to answer that, we have to recap what are the European and Dutch perspectives on offshore wind development. So if we take the European perspective, then the Green Deal was closed in December 2019. It was put into law in 2021, and also in 2021, the Fit for 55 package was launched. Basically, it states that we want to be climate neutral in 2050, and we want to have a fully CO2-free energy system. Also, we want to have a 55% reduction of greenhouse gases in 2030, this with respect to the 1990 year. Also, we want to have a 40% share of renewable energy in the energy mix of 2030. Also, last year, as a response to the war in Ukraine, Repower EU was launched. And basically it states that we don't want to be dependent anymore on Russian gas. This likely will accelerate the energy transition. Also, we want to increase the share of renewable electricity in the energy mix in 2030 from 40% to 45%. There are not really explicit wind goals in Repower EU, but there are on solar energy, heat pumps, and hydrogen, and so forth. However, there is an indirect impact on wind to the acceleration of the permitting processes and the use of sustainable energy industrial processes. Last, there was the Esbjerg Declaration signed in May last year, where Germany, Denmark, Belgium, and the Netherlands decided to develop together the North Sea as a European green power plant with multiple connected offshore energy projects and hubs. The goal is to have an at least installed capacity of 65 gigawatt in 2030 and at least 150 gigawatt offshore wind capacity installed in 2050. The goal for offshore produced green hydrogen is to have 20 gigawatt production capacity in 2030. If we then move on to the Dutch perspective of offshore wind development, then, and particularly looking at the route towards 2030, then the goal for 2030 is to have 21 gigawatt installed capacity. Latest news is that the Hollandse Kust West, Lot 6 and 7 were appointed end of last year. Here, RWE, appointed Lot 7, will build 760 megawatt of wind power, which is an equivalent to around 1 million households. Also, they will develop 600 megawatt of electrolysis and 225 megawatt of e-boilers. Next to that, Shell and Eneco have been appointed Hollandse Kust West Lot 6, and they will also develop 760 megawatt of wind power. This lot is, however, more focused on ecological aspects. Then if we look at the current status and see what is currently operational, being built or being tendered, then that sums up to about 6 gigawatt. Later this year, the IJmuiden lot will be tendered, and that is equivalent to 4 gigawatt. That means that from 2024 to 2030, another 11 to 13 gigawatt will be tendered and developed. However, things do not stop in 2030, and if we consider the pathway towards 2050, then we want again to be fully CO2-free in our energy system in 2050. And the intermediate steps is that we want to have an installed capacity of offshore wind of 21 gigawatt in 2030, 50 gigawatt in 2040, and 70 gigawatt in 2050. The wind farms will be larger areas and further from the coast. Means that we'll go from a lot-based approach to a more hub-based approach. Here, infrastructure is key, and that will all make sure that there is more flexibility in the energy system that is so desperately needed. Also, wind energy will be converted to hydrogen at sea. And focusing on the last aspects, it is foreseen that we will have various demonstration projects, offshore hydrogen demonstration projects already before 2030 in order to secure the large amount of production later on in the decades to come. Particularly, we want to have a pilot of 100 megawatt as part of a planned wind farm and independently a separate hydrogen project demonstration of about 500 megawatt. What does that mean for the research we're performing in the Netherlands? Well, the R&D we execute, should be supporting this climate agreement. Particularly, the top sector energy has formulated a so-called Mission A. Again, that is the fully CO2-free electricity system in 2050. And also, they have developed a multi-annual mission-driven innovation program around it to secure this goal. And particularly the one on of interest is the one on renewable offshore electricity, so-called MMIP1. The TKI Wind op Zee is responsible for the execution of this program, and as TNO, we have aligned our R&D program with this so-called multi-annual mission-driven innovation program 1 on renewable offshore electricity. What do we then explicitly do? Well, the first step is to look at so-called market mechanisms and business cases. So looking at future scenarios in 2030 or in 2050, what market mechanisms do we expect and what does that mean for business cases of these projects? Then we look at so-called concept design of this coupled system. So offshore wind coupled to hydrogen production, offshore wind coupled to floating solar and so forth. And as a next step, we try to model that using our advanced energy measurement systems tools. And as a step further, also try to optimize them using control systems. The last step is to validate those in real, and particularly, for instance, at our Switch facility. So in this approach, you can see that the market mechanisms and business cases was explicitly part of our first webinar in last November, and that the validation and demonstration is now explicitly part of this webinar. As I said in the introduction, we will attack that from the 3 different perspectives. Each of the presenters here will showcase that. But before we go there, what is actually the Switch facility? Well, actually it is a hybrid renewable power plant laboratory, an open innovation facility with various connected components at scale. It is a collaboration between TNO and Wageningen Research, sponsored by our Ministry of Economic Affairs and Climate. Physically, it is located near Lelystad. So through research into hybrid sustainable power plants, this lab contributes to accelerating the energy transition. Each of the technologies inside the facility is approximately at size. We will have 6 turbines of 6 turbines of 10 kilowatt each. We will have 120 solar panels, equivalent to 45 kilowatt peak power, a battery that is able to store 50 kilowatt hours on energy, an electrolyzer of 25 kilowatts, and a weak grid, and a grid that supports that all. Beyond that, we have a measurement system operational that measures the operational conditions, the meteorological conditions, power production, and so forth. Also, we have a reconfigurable grid connection to emulate a weak grid. It can be fully deployed for research purposes, whatever the need is. And it's also good to mention that there is plenty of room for expansion, and this in close collaboration with industry if there is a specific need. So what will we have around summer of this year? We will have a fully controllable hardware, from energy generation and storage technologies to grid simulation. We will have a coherent data set, also with real-time weather data, power production data, and market conditions data. And we have plenty of space for expansion, as I said already. For instance, you can think of power to hydrogen, power to heat, and other generation technologies could be tested there. So with that, I have come to the end of my introduction, and I would now give the floor to my colleague Iratxe. Iratxe, the floor is yours.
Thank you very much, Jan Willem. Good afternoon, all. So now I'm going to present what TNO develops and do with the energy management systems for hybrid plants, not only on the modeling, but also on the validation and demonstration phase, and how the Switch Lab laboratory is being used, with showing to you 2 different examples of use cases. So to accelerate the massive amounts of wind power that are coming in the coming years and to integrate into the system and with other technologies, it is crucial to understand and also to represent what are the market challenges. So the increase of renewable capacity, how are we going to represent the weather dependency and the variability of the wind and solar, the industrial electrification growth and how it's gonna grow with respect to the increase of renewable capacity, expansion of the interconnection, how are we going to send the energy flows from the offshore wind to the land, and reinforce the transmission power grid and distribution network. Of course, the provision of conversion and storage options are as well very important and relevant to provide flexibility to all the system and to avoid the congestion problems. To address those main challenges, TNO developed smart schemes to operate renewable generation, storage and conversion, and this is called the one flexible hybrid power system that it can be represented in land conditions but also at the sea. In this case, the main representation is the supply of the renewables to as well represent the variability mainly of the wind and the solar energy losses and curtailment reduction, and the green hydrogen production and conversion to other energy carriers. So the energy management system represents the infrastructure layout at large. In this case, the energy management system simulates the optimal available infrastructure not to have energy losses, what is the match of the supply and demand of specific hybrid schemes. We do as well evaluations and calculations of the levelized cost of energy of hydrogen and as well of storage, both inland and offshore, on different configurations. For example, if electrolyzer is onshore, what if the wind farm is connected directly to the onshore with the cables, or if the electrolyzer is in the platform, we need to represent the connections with the cables to the offshore station, but also the pipelines from the platform to the shore. And also if the electrolyzer is as well, for example, integrated in the wind turbine. In this energy management system, we are also able to apply techno-economic analysis and evaluations, and consisting of profit maximization and as well minimizing the cost to help and support the industry with their businesses. In parallel, the energy management system as well simulates the electrical and control integration and the operational strategies. This consists mainly on the concept design and feasibility studies for different configuration of hybrid power systems, depends on what are the consortia that we are forming. We focus on asset dimensioning and utilization of each asset. We also look at the electrical connection and how this, the grid connection is looking at the energy flows and how to maximize and reduce the curtailment of the energy. We look at well as the transmission system, cable pooling. That means that how can we combine the infrastructure and reduce the cost of the infrastructure, as well as the routing, for example, to be compatible with spatial planning in case as well of the offshore, on the offshore conditions. And as well, we do the control optimization on the hybrid power system. In this case, we use a predictor to forecast the weather on the day ahead, and as well the optimizer to optimize its assets. Looking for the long term, the energy management system, we also using this to simulate future energy islands for the long term as well on the multi-hubs. So here I saw the first use case. It is within a project called Magpie, and we support the green ports to be more sustainable. In this case, we address the missing link between the green energy supply and the green energy use in port-related activities, for example, the transport. And in particular, there is a smart powerhouse in Port of Rotterdam, which connects onshore wind turbines with a battery to provide green electricity to the vessel. The Switch laboratory here is employed to make the testing validation of the direct connection between the battery and the onshore wind turbines. And what we are testing is the optimization of the utilization of the battery, and as well maximization of the utilization of the wind farm in order to avoid the peak shavings and to provide flexibility to the system. The second use case, it is a new project called SenseUp. The main goal is the optimization of offshore energy systems, and it accelerates the potential rollout of offshore floating solar into offshore renewable energy system. Looking at the hybrid power optimization at TNO, we will optimize the system integration of offshore energy system modules, considering not only offshore wind and floating solar, but also the production of hydrogen, storage, battery, cable, and pipes. And the Switch laboratory will be used here to test and validate the direct connection between the solar panels, the wind turbines as a green suppliers to produce directly green hydrogen. And the next step is to demonstrate this in offshore conditions located in the Q13A platform, that it is a platform where the Poseidon project is launched. So to finalize and to wrap up this small representation on the energy management system, I have shown here the wide range of application that the Switch Lab can be applied for, not only for support the ports on making more sustainable, but also to avoid congestion problems, also the acceleration of offshore and the connection of offshore renewable energy, and to support the rollout of the offshore green hydrogen at the North Sea. So for me, that's all. Thank you very much. I give it to you, Milan.
Thank you, Iratxe, for this, for your viewpoint on energy management systems and the connection to Switch in that respect. Then we move on to you, Chris. Can you shine your light, please, on weak grids in rural areas? Floor is yours.
Yeah, thank you, Jan Willem. Yes, I will do that. First, show my opening slide. Yes, weak grids in rural areas, so I will focus on what happens on land. And I hope to show you that both hydrogen production and net congestion problem solving could be part of these items. But first, some numbers. I think numbers that you might already know, but it's good to mention them again. We have a national ambition to have 35 terawatt hours of renewable electricity on land. Good news, perhaps we were at 22 terawatt hours by the end of 21. So there's only 13 to go, but they may be the hardest. And half of that was solar and half of that was wind. And just another number of 55 terawatt hours, and that is the cumulative ambition of all the regional energy strategies in the Netherlands. So there's even more than a 35. So there is a lot of interest for companies and organizations to take part of the energy transition. And the last number is 45%, which is the percentage of farmers that produce renewable energy as we speak. And that also means that there are 55 that do not do that. But I know of many of them that would very much like to participate, but they cannot. And of course, we know the cause of that, and that is the grid congestion in the Netherlands. You can see the orange and red colors are in the rural areas in north, south, and the central and east of the country. And that also hinders a lot of organizations to participate. And I think it's good to know that also for the regional energy strategies that smart energy hubs will also be an interesting solution to this problem. And I hope to explain that a little bit to you. That first, maybe go into the energy use of agriculture a little bit deeper, because we produce a lot in agriculture, but we also use a lot. And what we use most is natural gas, and that is obviously the greenhouses in the Netherlands, which use a lot of natural gas, but also put a lot of electricity on the grid with their combined heat and power units, and that is why the net electricity balance is negative. And we also are using 7.7 terawatt hours of renewable energy as we speak. So I think agriculture can produce a lot, can produce more, and become also more sustainable at the same time. And that is an opportunity for us to match production and use of regional energy locally. Now, my next slide. Yes, I've done some calculations for you. Taking a typical farm in Flevoland, for instance, where you have one windmill and solar capacity of 3.2 megawatt. And if you have a 2,000 kilowatt grid connection, you will not have much curtailment when the solar panels are east-west oriented. And this 1% will only allow you for 1.6 tons of hydrogen to be produced. If you increase the solar capacity, it will increase the curtailment and also the hydrogen production. But if you double the wind capacity, it gets more serious. You get a lot of curtailment problems, but at the same time get a lot of hydrogen production also, and that can go up to 69 tons. And if I take our own farm, 750 hectares in Lelystad, then we use 33 tons of hydrogen. And then you would say you can be quite self-sufficient, but that is not really the case. Because here we look at the diesel and hopefully in the future hydrogen use throughout the year. And you see a high peak in the autumn. And that is why when we take our potatoes and onions and sugar beet from the land, it costs a lot of diesel and also hydrogen. And you cannot imagine that we would store enough hydrogen to match this demand throughout the year. So we will also not only be exporting hydrogen, but also importing hydrogen, especially at that time in the year. Now, how would such a local grid look like? Obviously, wind and solar, the combination is very important because you get a better spreading of the energy production across the year. A battery, of course, electrolyzer that you can put hydrogen in a tube trailer or in a tractor, or maybe even put it on a pipeline. And of course, we need a connection to the grid because at times when the grid energy is cheap and abundant, we can also use that in this grid and thus contribute to easing the congestion problem. Now, this is an artist's impression of a project that is, has set off, and that is a large unit of electrolyzer capacity and battery with a lot of wind energy and solar panels. And we are participating in that, and hopefully in 2025, we will get hydrogen from that facility to our farm and then use that on our farm. Now, to end and to conclude, I think that it is clear that agriculture can still produce a lot of renewable energy, along with others, of course, and we really want to. And if we would have unchanged grid capacity, then there will be ample opportunities to produce hydrogen and then replace diesel and become more sustainable on our farm, and then even export hydrogen to other users nearby. And I think that if you look at agriculture, it is very variable across the country, from region to region, from city to city, so to speak, and it is always different. And that is why we need to design the optimum grid for each situation. And that is where I think Switch can come in and could be very helpful to make that happen. So I've come to an end of my presentation. Thank you very much for listening, and I'll give the word to Jan-Willem again.
Thank you, Chris, for this interesting viewpoint on the energy system and from agricultural point of view. I think it's quite insightful. Yeah, and then we move on to you, Floor. So I will give the floor to Floor.
Thank you.
The Port of Rotterdam perspective.
Yes, I would like to tell you some more about our shore power program in the Port of Rotterdam for seagoing vessels. And I've 3 slides with me. One is about our shore power strategy. The second one is about our main focus. And the third one, I would like to tell you more about our pilot. It's a pilot about the off-grid shore power. That we are preparing right now. So I will go to the first slide. It's a shore power strategy and projects. In 2020, we presented our strategy. We've developed that with the city of Rotterdam, and it's about 8 till 10 shore power projects in 2025 to have this up and running. And the ambition is to have 90% of the ship visits in 2030 with shore power. That's the ambition. And you see here on the map an overview of the Port of Rotterdam area. At the left side, the container ships at Maasvlakte. And at the right side, the container vessels near the Erasmus Bridge, so the inner city. So that's the area, and our strategy contains 3 pillars, and we're working on all the 3. The first pillar is, and I forgot to say, but it's always shore power where it makes sense. That's the starting point of our strategy, and the first pillar focus on improving the quality of the living environment. So it's about shore power for ships close to the residential areas. So that's the breakbulk, for example, the breakbulk segments and other vessel types that are close to. The second pillar, that's about the countdown, the large steps forward make and countdown of the emission reductions of CO2 and nitrogen. And then we focus on the container ships, the ferries, the offshore vessels, the roll-on roll-off vessels, and also the cruise ships. The cruise ships are a special one because they're in pillar 1, because close to the residential areas, and pillar 2 because of the countdown of the emissions. And then we have pillar 3, and that's a special one. A special one in the sense of it's about encouraging of the innovation and the standardization where necessary. And it's necessary for the low voltage segment. That's also the segment for the smaller vessels in the break bulk segments, for example. And also it focuses on to develop ATEX-proof safety connection for the liquid bulk, so to plug in the tankers with shore power. In that pillar, we're working with international other ports. So we are joining the World Port Climate Action Program, and we learn a lot in the collaboration with the port like Hamburg or Los Angeles Beach, Los Angeles, where it's a front runner, Los Angeles Port, I'll say. So that's the idea about the international collaboration, building up coalitions, and to exchange knowledge. Then, important to say, we have also Rotterdam Shore Power. Rotterdam Shore Power offers shore power as a service, and it's a joint venture between the Port of Rotterdam and Eneco, Sustainable Energy Company. And offer shore power as a service means it develops, it invests, it maintains, it offers the terminals the whole package for shore power. So that's in short our strategy, and there's a lot of work to do. And that brings us to the second slide. Act where it makes sense. Well, our main focus is on the segment that will be OPS mandatory in 2030. That's to be expected. Based on the Fit for 55 measures. It's about container, cruise and ferry segments. And the other one is to run OPS in the urban areas, the break bulk. You see here at the slide at the left a picture of the Waal-Eemhaven area. And at the other hand, the cruise port Rotterdam. We're now working on the project, and we hope to deliver shore power next year to the cruise vessels. And right below you see the big container vessel as well at deep sea terminal Maasvlakte. So as a port authority, we are working now on 3 projects. That's for the Lloyd Parkkade, the inner city of Rotterdam, and also for the cruise port Rotterdam for the shore power for the cruise. And as Rotterdam Shore Power, we're working for, we have now 2 projects in construction phase. That's DFDS in Vlaardingen, and that's also Boskalis in the Waalhaven. So this gives you an actual overview in what we are doing now. Then I will jump to another part, and that's the pilot phase B. That's the off-grid shore power solution. Because we're not only focusing on projects with a grid connection, this is the other side, to see, well, can we also use off-grid shore power solutions that will be mobile? For example, you can use it at terminals with a low occupancy rate or where there's a shortfall of the grid connection and capacity. So we focus on testing how it works, and also how it works on a terminal that's in fully business in operation. How can we fit in the system in that situation? And we also want to test an innovative cable management system. So that's the pilot. It's now in preparation stage. Our partner is Steinweg, and together with the liner Cargo W. And we hope to get live in the mid of this year. Then that we can start, and I think we can learn a lot of that. So this was my presentation. Over to you. Thank you.
Very good, Floor. Yeah, it's really interesting. And I think we have had 3 different perspectives from the generation side and managing that, from the, let's say, agricultural side, and from the Port of Rotterdam side. So all centered around this energy management and energy system, which fits as a demonstration facility. We have quite some questions coming in the chat. That is very insightful. Thanks for that. It might be that we'll not be able to address them all. However, be assured that we get them and we'll try to answer them afterwards. So yeah, I'm sorry for not being able to address them all. Also, we got a couple of questions whether these slides will become available. I can tell you that this whole webinar can be watched back on demand from tomorrow onwards. So those were just two organizational remarks. Floor, you've shed your light on shore powering. How do you think could Switch help in the developments you foresee?
Yeah, I think Switch can help us because at Switch Lab we can test it before we go live. So we can see because shore power, that's an important thing in the full energy transition, and that's also about reshaping a new system. And as a team, we're also thinking about and working on things like, well, if we put a battery into the shore power system, can this help us with peak shaving, and also for balancing the grid? And because for shore power there's a base load use for the vessels, but also the vessels uses the peak power because of the pumping, cranes, and other things on board. Yeah. So I think Switch Lab can help us to see how it works before we go live.
Yeah, very good. Are you also looking at shore hydrogen terminals in the port? It's a question that comes in.
About what kind of hydrogen terminals?
Well, I think now the shore powering is electricity.
Yeah, Well, for the off-grid pilot, we're looking for a system that runs on hydrogen. Yeah, maybe it's. We have asked you, Tino, to advise us on the technical specification and to see if it works with the power demand of the vessels and the amount of hydrogen that is needed. So yes, we are also with that pilot. We will test that. Yeah.
Okay, very good.
If it works in practice, that.
Yes.
Yeah. Otherwise, we shift to other alternative fuels. Yeah.
And maybe on that respect, I'm just reading out loud. What about using CO2 and hydrogen to produce kerosene or diesel? Is that possible, or is that?
Well, that's more related to alternative fuels, the question. So that's not, I think, related to shore power. Okay. Because that's more battery or other grid connected related. But maybe here the other members can tell more.
The only thing I can say that I know about this development, that it is working, but I think the question relates to could that happen in Rotterdam Port?
Yeah. As a Rotterdam Port, we're focusing for the import of hydrogen. Mm-hmm. And hydrogen comes in with a vessel as ammonia. So we are looking for the import of hydrogen and also for the electrolyzers in the close future will also produce it in our port. So import and export.
Very good.
Or no, import and for the use of our own port. Yeah. That's the right answer. Yeah.
Okay. Can you also shed some light where the green energy is coming from?
Yes. At Rozenburg, for the Herema shore power connection, it's a direct link between our e-house and the wind farm at Rozenburg. So that's from the wind. And at the other projects, well, we're looking for when it's from the grid, then it's based on certificates of origin. So it's green power certificate. And well, for the off-grid solution, we are looking for to use alternative fuels or maybe hydrogen. Yeah. So
okay.
That's
very good.
Yeah.
Very good. I have also some various questions coming in on the actual, let's say, Switch facility. What components are there? Do you know, for instance, what type of electrolyzer is being used and what type of batteries? Can you shed your light on that?
The electrolyzer is a PEM electrolyzer. Mm-hmm. The battery I don't know actually, but well, if some people would like to know, they can always visit us and then see for themselves.
Yeah. I also got a number of questions about is this also here, is this also there, like considering biofuels and stuff like that. Can you shed your light on that as well?
Well, biofuels in general, I think it is regarded as not being very sustainable. So we are not working on that in general, but I think methane could be an interesting biofuel if you would have the feed to produce that. And that could be grass, a roadside grass, or grass from nature areas. We are experimenting with that, and also manure from dairy farms.
Okay. I think in your presentation you also made the link with SWITCH already just a little bit, but in the research, Wageningen Research is performing. How do you see that connection happening
with
SWITCH?
Well, I think that, as I said, if in agriculture we would like to become more sustainable, we need to find a solution for diesel, and hydrogen is the best possible one, and we could produce them ourselves. So I think the connection to switches is that I think that farms or a group of farms could install such a local grid and then profit from them themselves, and even profit from hydrogen that they produce and put on pipelines or sell to others. Yeah. So I think it's a great opportunity for agriculture to participate more.
Yeah. And are there, it's also a question from the chat, already farmers that use hydrogen? Is that already taking place?
Not, but there are many that would very much like to do that. I think the thing that is really standing in the way is that they need permits for that. And I think, of course, buying electrolyzers is also something that is very time consuming. And I think also that there is not enough, there are no machinery at the moment that use hydrogen. And that, I think, is the biggest bottleneck.
People also wonder whether there will be a connection to the backbone. So, like you said, on the exporting side. What are plans there?
Well, actually, for us in Lelystad, if everything goes as planned, then the backbone will be from the Maxima Centrale, which is close to us, to Zwolle, and then the backbone will be quite near to our facilities. So we will be very close and can connect to that backbone.
Yeah. And just to get an order of magnitude, do you know how much in SWITCH is produced with respect to hydrogen?
That's in kilograms. That is not much, because we only have 25 kilowatt. So that's not much. It's just for the purpose of doing experiments. But in the amount of hydrogen being produced nearby will be in the order of hundreds of megawatts. So that's quite serious.
Yeah. Okay. Very good. Very good.
Yeah.
Question to you, Iratxe. So developers are already developing hybrid power plants offshore at Hollandse Kust Noord and so forth. So what do you think then is the added value of SWITCH? Aren't we just too late?
No, absolutely not. Well, I just mentioned before that it is the perfect timing as well to test and validate the models, the energy management system, before going to offshore conditions. Now, in the introduction, it was mentioned the aspects of the upscaling of green offshore hydrogen together with the next tenders, for example, for IJmuidenver, sorry. But also on regards of the off-takers is very important, who is going to take this green supply. So the testing of matching supply and demand, the energy flows, and within the whole hybrid system, it is a really great added opportunity to test in the SWITCH lab before going live.
Okay, very good. I just remembered there was another question. Yeah, and I think that is more or less related. So the question is, we are well positioned around the development of wind installations and new solutions. We have a lot of knowledge. Do you see new business models to commercialize this knowledge abroad or inside, and how to do that?
Yeah, absolutely. So very well positioned in the Netherlands for the developers, but how to connect the wind with a battery to use as a peak savings, or maybe when do you convert the wind power supply into green hydrogen or directly to power? to have central or decentral, this is a business model that we need to investigate and to test as well what is the profitability for the specific business.
Yeah.
So absolutely, I think that there are new markets there.
Okay, very good, very good. I have a question to you, Floor.
Yes.
When do you expect that hydrogen and ammonia import could be up and going in Rotterdam?
Well, that's a good question. One of my colleagues is running that program. That's about the hydrogen. So I will say to take a look at our website and check the schedules and check the program for hydrogen and ammonia. Because we're working on that, and there's a high ambition by the port.
Yeah.
It's an important thing in the energy transition that's going on in the port now for the alternative fuels, to bring them in and also to produce them in the port.
Okay, okay, yeah. One is also asking, there is a lot of hype about producing hydrogen, but are we able to consume or sell all this hydrogen? And what about the infrastructure needed to transport? So whoever wants to take this.
There's a really huge fan base for the hydrogen. I miss shore power.
Yeah.
So please again, take a look at the website of the Port of Rotterdam and contact my colleagues, because they can tell much more about hydrogen and the ambition of the port for the alternative fuels and the hydrogen. Yeah.
Yeah.
Maybe just to add that, of course, hydrogen is not something that we haven't used so far. We are using that in heavy industries already for a long time. So, but that is grey. And if it's green, then they will, of course, be very welcome to use that and take that in. And of course, there's also a lot of demand that still needs to be developed. And that's always a chicken and egg situation that we need to break through. So,
And as well, there will be hydrogen demand, but as well, we need as well to think about what are the main challenges. We need to reinforce the transmission grid and as well the infrastructure, but the main goal is to reduce conventional power. And hydrogen, batteries, and green supply are the alternatives for that.
Yeah,
absolutely.
Okay, very good.
Yeah.
We had a typical question for you on the batteries at Switch. Perhaps the same also holds for you. Do you know what battery is being used for the shore powering?
Well, actually, there's not a battery yet for the shore power.
Yeah.
So it's in a development stage. If we can say, well, will a battery contribute to the system?
Yeah.
So in that stage of the project.
Okay.
So no, that's the answer.
Okay, that's short and sweet indeed. There's a question from a person coming in. He says, can you share some insights about the shore power test results at the Parkade? The setup has been removed some years ago, but the results, are they published? And are they available?
Yes, I think they are available. And it was the first live test for shore power at Parkade with some systems to see how it works, and also to gain the knowledge together with the shipping lines, the ship owners. And with the results from there, we say, well, okay, this is the Parkade, a public key. But now it's time for test it at Steinweg in a fully operational setup, and also with an innovative cable management system. So pilot phase B is standing on the results and also the knowledge gained on pilot A. Yeah.
Okay, very good. Thanks for that. On behalf of the question addresser. Maybe a question to you, Chris, is the energy consumption in greenhouses mainly associated with heating?
Yes. Well, not only heating, but heating is the largest one. Of course, they also need electricity for lighting, but heating is very important.
Yeah. Okay. So that's one of the main.
Absolutely. Yeah. So, and they are also in greenhouses looking for combined heat and power units that can also process hydrogen.
Okay, very good. Let me see. A lot of hydrogen indeed. Maybe to you, Irache, and I think this is on the infrastructure part and the grid operators. So yeah, congestion has been mentioned. How was, let's say, our viewpoint on that, and how are we tackling that also perhaps together with the operators? Can you shed your light on that?
Yeah, so at this moment we use the energy management system to simulate the energy flows if we have a virtual wind farm, offshore wind farm, in this case the operators, and how this green power supply can introduce or fit to the grid, how can be transmission, and also what would be the main congestion points. And then, based on the hybrid system, what are the best solutions if installing a battery, producing hydrogen, as well depending on the off-taker. So I would say that there are a wide range of option and combination of the hybrid systems based on the power supply, green power supply from the operator side, and also what are the combinations of the technologies that we can consider and the off-takers. It is different that if the power supply can go to a specific off-taker for industrial purposes, maybe to the transport sector, to the residential area, so we can look together with the energy management system to different problems.
Yeah, okay, very good. And it's already addressing, in my view, yet another use case. We have addressed here 3 different use cases, and this is already
exactly
a 4th one.
Yeah.
And actually that is a bridge to my question. What use cases could you think of where Switch could play an interesting role in, or crucial role in, perhaps?
Yeah, so we mentioned here to support the ports and also the vessels to electrify it. We also can help industry for the electrification with green power supply. We can also support the acceleration of offshore renewables, but also the rollout of hydrogen, that it is also the significant part of this energy transition. So this is just an example, list examples of what can be the applications for the Switch Lab. But as you see, there are from one side the port, the other's congestion, offshore conditions, onshore, smart grids, the business parks, for example, that can provide flexibility to the residential areas, to the transport sector. But what is the transition that it will take in the North Sea and also to the onshore conditions with all the sectors? So it's very, very wide, and it is very specific depending on who can be interested in applying to the Switch facilities.
Yes, yes. Well, thank you for sharing your thoughts on that. Yeah, as a matter of fact, we're already getting to the end of this webinar. Yeah, we have had a lot of questions, and I think also a lot of interesting discussions. At least I found it very interesting. I hope you found it interesting as well. As I said, this webinar can be watched back from tomorrow onwards. And also, thanks again for all the questions and for listening, of course. We have received your questions and are able to follow up on that as well, so please be aware of that. Before we close off, I have 2 requests to you. One is that if you, perhaps based on this webinar, are interested in collaboration with us on the Switch facility, then please let us know. If everything is okay, then there should now be a pop-up in your screen in which you can show your interest. So if that is the case, again, please do so. And apart from that, of course, we also value your views on how we did this webinar. So we also appreciate if you could evaluate that. And if everything is okay, then there will be a second pop-up in your screen, which you can use to evaluate us. Like I said, we would very much appreciate that if you could do that. Yeah, and those are actually the closing remarks from my side to you. Again, thank you very much for your attention. And I would also take the opportunity to thank the speakers here in the studio. Irache, Chris, and Floor, thank you very much for your contributions. Thank you. And hopefully until a next time.
Thank you very much.